Here we have a SAT math question. Okay, let's go with the information. Which of the following is true about the values of 2 to the x to the power and 2x positive 2 for x greater than 0? And option A says for all x greater than 0, it is true that 2 to the x to the power less than 2x positive 2. And option B says for all x greater than 0, it is true that 2 to the x to the power greater than 2x positive 2. And also we have some different stuff in option C and option D. According to the question, we have to discuss the values of the two expressions 2 to the x to the power 2x positive 2 in the given domain, that is x greater than 0. Okay, now let's consider the first expression, which is exponential, because we have variable at the exponent. So specifically, we have a positive variable at the exponent, and also this x takes only positive values according to the condition over here. And also this is linear. So whenever we have two expressions, one is exponential and the other one is linear, and also the exponential expression is having a positive variable at the exponent, and the variable x takes only positive values. So for all the values of x in the given domain, so the values of the first expression 2 to the x to the power, the values of the second expression 2x positive 2 cannot be in the same relation. That is like according to option A. So for all x greater than 0, that is whatever value we consider in the given domain, so always this 2 to the x to the power is less than this 2x positive 2. So that's not possible. So it will change initially. So this value may be smaller and this value may be larger. But after a particular value of x, so it will become larger and it will become smaller. So we can reject option A. And for the same reason, we can reject option B. That is for all the values of x in the given domain. So we cannot expect the same relation between the values of the two expressions. So because option B says for all the values in the given domain, so always is 2 to the x to the power is greater than 2x positive 2. That's not possible. So we can reject option B also. Anyways, we can verify again this option A and B also. So maybe option C or option D can be correct. So for that, we have to do some calculations. So for that, what I'm going to do is I'm going to consider some random values in the given domain, that is x greater than 0. To make the calculation process easier, I'm going to consider only the integer values so that x greater than 0. So the first integer value which is greater than 0 is 1. So now I'm considering value 1 for x. So now what I'm going to do is I'm going to plug in x equals to 1 into the two expressions given. Let me do it. So when I plug in into the first expression, it will become 2 to the first power, which is equal to 2. So when I plug in into the second expression, it will be 2 times 1 positive 2, which is equal to 2 times 1 is 2, 2 plus 2 is 4. Okay, for the first value of x, that is when x is equal to 1, so the value given by 2 to the x to the power is smaller than the value given by the expression 2x positive 2, because here we have 2, here we have 4. Okay, now let me take the next integer value, that is 2 for x. Now let me plug in 2 for x into the given expression. Then I'm getting 2 to the second power, which is equal to 4. And 2 times 2 positive 2, which is equal to 2 times 2 is 4. 4 positive is 6. Again, the value given by this exponential expression 2 to the x to the power is smaller than the value given by the linear expression 2x positive 2, because 4 is less than 6. Okay, now let me take the next value, next integer value. So that is x equals to 3. Then we get 2 to the third power equals to 8. Then 2 times 3 positive 2, which is equal to 2 times is 6. 6 positive is 8. So when x equals to 3, I'm getting the same value for both the expression 2 to the x power and 2x positive 2. Okay, now let me plug in x equals to 4. Let me do it. So 2 to the fourth power, the value of 2 to the fourth power is 16. And then 2 times 4 positive 2, which is equal to 2 times 4 is 8. 8 positive 2 is 10. Okay, at x equals to 4, the value given by this expression 2 to the x to the power is larger than the value given by the linear expression 2x positive 2. Anyways, let me do it for one more value. That is, let me plug in x equals to 5, the next integer. Then we get 2 to the fifth power, which is equal to 32. Then 2 times 5 positive 2 equals to 2 times 5 is 10. 10 positive 2 is 12. Okay, so even for x equals to 5, we get a larger value for the exponential expression than the linear expression. So like before x equals to 3, so the value given by this one, the exponential expression 2 to the x to the power is smaller. X equals to 3, both of them are having the same value, that is 8. After x equals to 3, that is x equals to 4, x equal to 5, the value given by this 2 to the x to the power is larger than the value given by this expression. So that is, we can write this situation, that is like when x takes a value between 0 and 3, that is when 0 less than x less than 3. So because these two integers 1 and 2 lie between 0 and 3. When x takes a value between 0 and 3, 2 to the x to the power is smaller than 2x positive 2. Okay, when x is taking a value greater than 3, so greater than 3 means these two values 4 and 5 come in this interval. So what's happening over here? 2 to the x to the power is larger than 2x positive 2. Okay, now look at this situation in option C and option D. So clearly we have this situation in option C. So instead of 3, they have used the constant C. That is when x takes a value between 0 and some constant. Some constant is 3. So this 2 to the x to the power, the value given by this exponential expression is smaller than the value given by the linear expression that has been explained over here, that is for x equals 1 and x equals 2. And if x is greater than c, that is when x takes a value greater than the same constant c, that is when x is greater than 3, so the value given by this 2 to the x to the power is greater than the value given by the linear expression that has been explained over here for x equals to 4 and x equals to 5. Okay, so the correct answer choice for this question is option C. So when I go to option D, the same situation we have, but in an opposite manner. That is when x takes a value between 0 and some constant, say 3. So the value given by this exponential expression is larger, but that's not possible because already we have done our working and clearly the value given by the exponential expression is smaller. But option D says the value given by the exponential expression is larger, but that's not possible. So we can reject option D also. So the correct answer choice for this question is option C.